talk is about security scanner we made for BAST. First, let me introduce ourselves. He's Pablo Ali, and I'm David Weil. Um, we were asked to make this scanner for instantiations. Um, yes, okay. More, more volume, please. Or maybe I can talk louder. Okay. This talk we have this agenda. We will be seeing the exploratory phase that we with what we started, and then how we converted that in a version one of a product, and then we will be seeing what the product is and the future step for it. So first things is why was a security scanner required? Well, many clients were asking for a security scanner because they need to comply with regulations and things. Many on the fintech area, but many other industries also require more compliance tests. Um, um, anytime more compliance is required. So many different industries were requiring that. So we started with this project in order to provide them with this tool, where we started to get used with Bast and created the vulnerability examples we were looking for by coding them in Bast, and then we needed to look up for them. We need a way to look up for them. So we started to use the static code tools we have available in Bast. In Bast, actually, there are two frameworks for doing static analysis. One is Code Critic QA, which is, I don't know, but since long time ago in Bast, and there is also a part of a more modern small lint framework. Each of them have pros and cons. We have already used small lint, and it offers um, some good, good, well, very well implemented searches for code optimizer. So we wanted to use that. And the main con we have was that it uses the RB parser, and Bast is using a different parser, which is not 100% compatible, but we work around the issues we had, so we we were able to still use a small lint for this. So we made a first proof of concept project where we uh, defined and attack these kind of issues like command injection, cross-site scripting, SQL injection, and also some more not not that kind of vulnerabilities, but more compliant things that uh, checks for things like having no passwords or keys or API tokens and leaked on the source code. Um, with that done, we the company decided to get that into a product. So that is where we started to work on what will be the product itself. That required many changes from apart the code scanning part. Um, the main thing was to convert the small int into something that will be more oriented to what we have. That for a small int, whatever you look up for is to a piece of code or a node in the AST tree. Um, but we needed to convert that into an abstraction that is the a detection, which corresponds um, to a rule detecting one kind of vulnerability with a severity which may be whitelist and which refers to documentation to how to mitigate the that issue, etc. And also, explained another issue that have is that is based in looking for one piece of code, again one AST node, and not to collect them all. They just look up for the first one and then they can look up for the next one and so on. But we wanted to collect them all to be able to present as a report or whatever. And also this this static analysis tool just look up for some code, some um, code structure, like a literal or a message, and 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 so on. But it doesn't performs. It it was not enough for what we were trying to do. So we added some what we call refinement pipeline, where we do process the detections we already have, and we are able to discard some false positives found. So let me tell you more about this. We have first mainly two kind of detections we handle. The first one, the sensitive content, are keys, API tokens, passwords, etc., and that are values, literal values embedded in the code, which we want to detect and inform the user. And on the other hand, we have some sensitive messages which may be used by a user and that are possible to have a vulnerability. So when talking about the sensitive content detections, which are passwords, as I say, the static analyzer let us do the first basic search step where we say which kind of nodes we want to detect and which that may be a simple literal node or maybe a message node invocation or an assignment, as you see there. And these are examples where we use those different type of nodes search. With the refinement step, we apply regular expression matching to understand if the values are corresponding to some known format values for tokens and passwords and etc. Um, this is one part of the one case for the refinement step. After the content detections, we have what we call sensitive message invocations that are invocation for messages which may be related to which may invoke what can be an insecure method, maybe to prepare an SQL statement or to create an HTML, which may lead um, into a cross-site scripting issue. In those cases, the static analyzer look up for a method invocation. Maybe, for example, in C-side, the problems are when you call HTML message with uh, with with data that will be not escaped, right? So to 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 detect that and be sure that is a vulnerability present, we need to understand that the invocation will be done on a receiver that is of the class HTML canvas, and we want to signal those cases in which the arguments of the invocations is not a literal, because if the user already invokes HTML, but he's using a literal expression with an HTML, there is no possibility for any attacker to get to abuse that, right? So in the case of this case, no, the invocations, the refinement step mostly consists in applying type inference to the receiver of the message and understand which kind of arguments are being used with that search, with that invocation. This is what I told before. Like, we need to understand that the receiver of HTML is an HTML canvas, or the receiver of shell or start or other messages is an instance or the class of process starter, right? So the static analyzer give us all the detection, all the invocations to HTML, to shell, and others. But we need to verify these two constraints in order to discard what will be false positives, right? Okay, next one. Okay, but to this point, we were detecting direct invocations of methods that we flag as sensitive, but the static analyzer doesn't handle indirect calls to or invocations to them. So this is something that is resolved by creating what is called a call graph, which is a graph with all the methods, where the methods are nodes and invocations are the edges of the graph. So you there mark the methods you want to you consider sensitive, and then you look up for works from those nodes into user code. But create the whole graph was expensive and memory bound. So we choose for an alternative that was precalculating all the functions with invoke those sensitive functions, right? So we have sensitive functions and sensitive and functions that invoke them in the Bust API. And we were interested in look up for those invocations in the user code. But when you start to create the precalculation of all those functions invoking sensitive functions, you get the snowball effect, where a lot of functions are listed, right? So the graph is massive. So we have to manually trim the graph by detecting which cases were impossible. Like, there are many cases, but for example, functions without arguments were not possible for the user to be abused. So those functions were discarded from the list. Um, and all of this, and applying this manual process um, many times, we were able to restrict the list of sensitive functions to something manageable. Um, Also, all these heuristics we applied to discard parts of the graph were applied in the rules in order to discard false positives too, because they applies also to user invocations of those functions. With that, we have a version of the scanner that scans all the code and leaves no function directly or indirectly invoking sensitive functions away. So it was good enough for what we were looking for. Okay, this is a bit of how it can be seen now. Um, to launch the scanner, you have a different ways to do that. If you want to do that manually from all the browsers in the system, there is a menu when you select a class, a category, or a class, a package, or a configuration, where you can, from the menu, trigger the scanner. Also, this is a screenshot of the code editor in Bast, and the code assistant have a plugin to invoke the security scanner. And you can also, when you generate a report from the scanner via the first way. This creates a script that you can run to perform the same scanning again in order to have a comparable setup to the run from a previous run. So there are three easy ways to run it, and for me the most simple is the automatic version. Um, One another feature that is very important for us is that we created some ways to whitelist vulnerabilities, which allows the users to handle and process them in different ways. For example, by marking some vulnerability um, like a false positive or one fix, or giving them priorities. And we made different methods, like with an atom in the code, with a code comment. We can also introduce a pragma, and we have also whitelist outside the code in a separate method in the class, where you can list your whitelisted functions. Um, Okay. Next. See, yes, we can also from the menu when you in the code you see underline each detection, and when it is whitelist, the underline is gray, and it is purple when it is not whitelist, and you have a menu in the tooltip. You have the option to automatically whitelist a detection or unwhitelist it if it was already whitelist. Okay. Here we have the results explorer for the scanner, which presents all the detections grouped by category and rule. Um, from here, you can open the report, the HTML report, in a window in a web browser, or you can export the detections to different formats. And here is the browse for a category of detection found. um, you can see all the detections and the code which trigger that. At this case, it is an HTML that comes from a variable, which you can be certain that it is not tainted, right? And exporting the data, for exporting data, we support different formats. One is JSON, where you have all the information about each detection. There is also the HTML wrapper we saw before, and you can customize the HTML wrapper with the template, and you can export the data also in a Sarif report, which is a common vulnerability format. And we support many different levels to hide or redact the code in order to make your scan output shareable with third parties or whatever. So you are not sharing sensitive information that may be included in the reports. So these are the levels of configuration. We have some presettings, and there is one custom where you can say exactly what you want to hide or redact. And this is the report with some statistics, the tool version, the report information, so when it occurred and over which application or class or configuration was it executed. And there is a results listing then, and this is one detection template. In the case this one is whitelisted, we have the lines explaining why it was whitelisted and where the detection is found, and the detection is highlighted, of course. Mm, I don't think there is anything more, so we are going try to see a demo. I don't know if we will try to move from computer.
Okay, we are running the scanner against our test suite and application. What is selected is the set of rules or categories. Now it's running. This is the result editor. Se te fue de vuelta. Okay. We are going to launch the report launcher. Now you have all the information about the report itself, a brief summary later, following, uh, ordered by the criticism of the vulnerability. And then we have a kind of index of the rules, of the detections, ordered by severity. And here is the detail for each rule numbered, okay? It describes all the characteristics of the detection. At the end of the report, okay, the you can see that the passwords that are hard coded in the source code are not shown in the report. This is because the redaction setting we set before. De abajo de todo. Now we're going to the bottom part. There is the script that you can use to rerun the scan exactly with the same input as it was run before. So you can reproduce the scan, not with no need to remember what you set as input. He ran the snippet code and he rerun the scanner with the same input. Yes, David is setting another combination of reduction settings. He exports the file. And we have no time to see the exported file. Well, that's all. We have no more time. Okay, future step.
Okay. We have some things to add to this. Still, we want to reduce the requirements we have now to make it shorter to be integrated in environment with for coding CI/CD environment, and we want to add more rules for different frameworks, and we also still need to add more data flow analysis in order to understand if some variable comes from a literal in some place different from the place where the functions are invoked. And also we want to extend the type inference engine to not only analyze one method but also methods that are invoked by the first method. We already have some we have these two false positive reduction settings already implemented. We are testing them, and that reduce also much more what the false positive way do we still have. So this is it. Thank you very much. I don't know if there are questions. We can reach us for questions also outside the talk, but whenever you want, we are ready.
Thank you.
Thank you.
Thanks. Thanks for the talk. I have maybe a stupid question, but how do you first mark the sensitive messages? I mean, you have to qualify some messages as sensitive. So how do you do that?
Well, the yeah, the first thing is what is nice about Seaside is that they already tell you the only sensitive place you have to pay care is to HTML message,
Mhm.
but for SQL injection and OS process, we did a manual research and we also created rules that made us that pointed out which methods were invoked via FFI,
Mhm.
and we review all those methods manually and label each parameter as sensitive or not, because there are parameters which are with something parameters, some parameters not. For example, parameters for um, just query parameterization are not sensitive, but the query parameterization of a query, the query itself will be sensitive, right?
Okay.
So we have to look at that manually, and we created a lot of an extra application with information about which functions we mark every function which is sensitive in that extra information. So yeah, that is a manual work
Maya.
in many
Okay.
cases.
And second question, is it possible some sort of dynamic scanning?
Yeah, we want to do that. I think there are plans for that, but we need to start at some point,
Yeah.
and maybe we can start to record where functions are called and create live filters for sensitive functions, etc. But we need to start at some point. But yeah, we want to do that too.
Great. Thanks.
Okay, thank you very much.